Hello, pre-algebra, and welcome. This is lesson 8.3, writing equations, in particular writing two-step equations. So we've begun to figure out how to solve two-step equations, and now we're going to learn how to write them, which means that we're going to be doing word problems. We're going to be given a scenario, and we have to turn the scenario into an equation, a two-step equation, and then we're going to be asked to solve it. So let's go ahead and get right in to this. So when we're asked to write a two-step equation, we may be given a problem like this, right? A power adapter costs $5 more than a docking station. The total cost of the accessories is $63. You can summarize this information by writing an equation. Right, so you have your tablet, your iPad Pro, your new one, right? You're thinking about getting a docking station for it, or maybe just getting another power adapter, or you're going to do both, docking station for your home, right? The power adapter so you can charge it at school, whatever the case may be. But this is the problem in words, right? We know that the power adapter costs $5 more than the docking station. And we also know the total cost. So if we look at this, we can kind of rewrite it in words, right? And so rewriting it, we're going to say docking station plus power adapter costs $63. So right here, we know cost, that word means this is an equal. Plus, we know we're going to have a plus sign, right? And now we just have to figure out what is docking station going to be and what is power adapter going to be. And we know that they are different. It just can't be the same number plus the same number because we know that the power adapter costs an additional $5, right? So if we look up here, it costs $5 more than the docking station. So if we look here, if we let D stands for the cost of the docking station, then we know that the power adapter costs $5 more than the docking station. So the power adapter is going to be docking station plus 5. So we're going to do plus another D and then plus 5. And we know that that's going to equal 63. And that's exactly what we have here. Right here we have, this is the docking station. And then the D plus 5 is our power adapter. And we were told in the equation, in the word problem, of course, what them added together is going to equal. So that means our equation is D plus 5 equals 63. And now we're going to have to solve it. Right? Although this problem doesn't necessarily ask us to solve it, we've just been asked to turn it into an equation. We can solve it. And I want to go ahead and solve it real quick for us. So D plus D is 2D plus 5 equals 63. We're going to subtract the 5 first. Remember, we start when we're undoing an equation, we go in reverse order of operation. So we're going to subtract 5 from this side, subtract 5 from that side. So 63 minus 5 is 58. And those cancel out, so we have 2D. And 58 divided by 2 is 29. So D equals 29. All right, so that's how we do that. So let's practice a little more here. Our first one, Zach has 6 shirts. This is 4 less than twice the number of shirts, which we are going to use in, right, to represent the number that Xavier has. So let's set this up. And here, all we're going to do is set up the equation. That's all we're asking. That's all that's being asked of us right now, is to set up the equation. We're not going to be asked to solve. So we just need to set up the equation here. So how do we set up this equation? How do we write this two-step equation? Well, Zach has 6 shirts. This is 4 less than twice the number of shirts in that Xavier has. First of all, where does it tell us where our equal sign is going to be? Right here. That is our equal sign. So that means that Zach has 6 shirts. That's going to be 6 equals whatever's over here on this side to our right. So 4 less than twice the number of shirts in that Xavier has. So Xavier has in shirts, and 6 is 4 less minus 4 than twice the number. So 2 times in, there's the twice the number. There's that part, and the 4 less is this part here. So again, we're going to write this as 6 equals 2 in minus 4. All right, let's move to the next one. 8 more than the quotient of a number y and -3 is -4. Now, the first thing I want to point out is we need to remember what quotient means, what operation quotient means, and this is a division operation. Okay, the other thing we need to be looking for is our equal sign, and is usually a good indicator that that is our equal sign. So we already know that this side of the equation is going to be equals 24. Now, the other thing we need to look for here is this 8 more. When it says 8 more, this is not a multiplication, this is a addition, so there's going to be a plus. So we have a plus sign, we have some division taking place, and we have our equal sign. So let's deal with the multiplication or division first. So 8 more than the quotient. So quotient of a number and -3. Ooh. Now this is, right, since it says quotient, this and is not a subtraction or an addition. And over here, this and here is not subtraction or addition. This is telling us the two numbers that are used in our division problem. So y and -3, we're just going to read them as they are given. So this is going to be y oops, I wanted to use yellow here for our division. Y divided by 3, and we have an 8 over here. Okay, so let's rewrite this without all the spaces. I'm going to write it in, use the same color. So y divided by 3, we can also write that as y over 3. That's another way to write division. Plus 8 equals 24. It could also be written, right? Since that plus 8, we could write it as we wrote it above. We could write it as 8 plus y over 3 equals 24. Both of those would be correct. This one here, right, more closely matches how the sentence reads, but this one here also works because we can add in any order that we want to. 2 more, just to make sure that we know what these words mean and we are comfortable setting these up. Jeremy has 13 baseball cards, which is 7 more than 1/5 the number M Michael has. So first let's look for the equal sign. So I'm using purple for that. So Jeremy has 13 baseball cards, which is 7 more. Okay, there's the word is, which is, so that's our equal sign, and the number over here, it says Jeremy has 13, so that's going to be 13. There's our equal sign. Okay, Now let's look and see. Our next thing that's going to be is 7 more than 1/5. Ooh, how do we write 1/5? Let's use red for that. So how do we write 1/5? Well, 1/5 is right. It's just simply written as 1/5. Okay, and it says that it's 1/5 the number M that Michael has. So 1/5 of the cards that Michael has, and now we have this 7 more. Well, we just saw that 7 more means 7 plus. Okay, so let's look at this. Did we get everything? So we have 13. 13 is there, good. And that's a which is an equal sign. We have 7. 7 more, that's a 7 plus, good. And 1/5, the number M. Yep, that's there. So we have everything in our equation. So if we were to rewrite this equation, and I'm just going to get rid of the spaces, this equation is going to look like 13 equals 7 plus 1/5 M, or 1 divided by 5 M. Just remember 1/5, 2/5, 3/5, 2/3. Those are all division problems, just like quotient is a division problem. All right, our last example. 4 more than 0.3 times a number, x, is -26. So again, let's go ahead and look for that equal sign. There it is 26. So that's an equals 26. Now let's go back. 4 more, that is an addition. 4 more than 3 times a number. Sorry, 0.3 times the number. So 0.3 times the number we're told is x. That's an unknown. So that's going to be, we're going to write that as 0.3x. That's this part here. Okay, looks like we have everything, right? We have 4 more. We have 0.3 times number x is 26. So our equation, our two-step equation, looks something like, oh, that should be a -26. I didn't write that there. I just saw that. Right, it's right here. I didn't write it there. So we can write it like that. Again, because we can do addition in any order, we could also write it like this: 0.3x plus 4 equals -26. And again, I'm doing it this way. This is perfectly acceptable because that is exactly how it's written in our sentence, but it is okay to reorder it. We can add in any order that we want to, and therefore this is also an acceptable way to write it. Sometimes when we actually solve for x, we find that it is a little easier to look at it in this order than it is in this order. Sometimes, at least for me. Okay, and it's okay to change that. All right. So sometimes in our real world problems, right, we saw some there, someone has, 3 more cards than half the number of cards that Mr. Jones has, something like that. Here we have a situation in which we are going to have a total, and then that total amount is going to increase at a constant rate by something until we reach another final total. And we can see this in an example like a walkathon, right? Where perhaps someone pledges a set amount, you just participate, here's some money, and then other people say, well, for every mile you walk or every half mile you walk, here is a little bit of money. So you are motivated to walk more miles. So here's the problem. Logan collected pledges for the charity walkathon. He will receive total contributions of $65.50 plus $21.75 for every mile that he walks. How many miles will he need to walk to raise $370? Again, as we started with, if we can kind of get rid of the words here, the parts that we really don't need as far as an equation goes, right? We can start crossing some things out. So the Logan part, that's interesting that his name is Logan, right? We kind of understand what a walkathon is, but that really doesn't come into our equation. So that's not part of our equation. He will receive total contributions of $65.50. Again, that's important information, but really all we need to know is that this is a fixed amount. This is a set amount. And here is a keyword, plus, that we're going to be doing some sort of operation. And then here is another key phrase, right? That he walks, we're not too worried about that. How many miles will he need to raise? 370. And so we can see that that 65 goes here, right? That plus is here. That 2175 is that part. And although we don't use the word raise down here, we have equals. We know that his goal is to get to 370. So that is an equals 370. Okay. Then if we, then if we look at up here, okay, we have an unknown. That per mile is an unknown, so we're going to let M stand for the number of miles Logan walks. So that gives us this term, 21.75 M, and that's also an operation, right? That's a simple equation, which is the contribution for walking in miles. So if we use the colors like we were just using, right, this 65 plus is going to be here. Our multiplication is going to be here, 21.75 M, right? So for every mile, so if he walks 2 miles, he raises $43 and what's that going to be? 50 cents, etc. And then our purple, our equation, the other side of the equation is 370. So that is our equation. Now, notice in our question, let's go back here. Notice in our question, we do have a question mark. We are actually asked to figure something out. We are asked to figure out how many miles he needs to walk. So now that we've set up the equation, we need to solve it, right? So to do that, we are just going to start to do things. And again, we start with our order of operations. We go in reverse order. So we are going to start with our subtraction and our addition to get rid of terms that we can subtract or add. So over here we have 65 plus 6550 plus something, so we can get rid of that. So if we subtract that on this side, what we do to one side, we have to do to the other side. We're now going to have an equation of 2175 M equals 304.50. And now we're going to divide both sides by 2175, because that's a multiplication, right? That's 21.75 times M, so that's multiplication. So that's going to get rid of that. And we're going to do on this side the same thing. And that is going to mean that we now have M equaling, so if you get out your calculator, 304.5 divided by 21.75, and we should have 14. And now we've solved it. So, right, Logan has to walk 14 miles. Okay. All right. So our last one. Jasmine bought 6 DVDs, all at the same price. The tax on her purchase was $5.04, and the total was $85.74. What was the price of each DVD? Notice we do need to solve for the price of each DVD. We need to answer that question, but before we can do that, we have to set up our two-step equation. So let's go ahead and look for our equal. The total was, that's it. Oops, I wanted to do that in purple. Let's change to purple. Here we are. So equals 85.74. She bought 6 DVDs, all at the same price. The tax on her purchase was $5.04. We don't have that word plus, but I know that it's going to be here. So, right, So we have the tax on her purchase was $5.04. That's not times anything, that's not right, there's no variable there. That is simply plus $5.04. So whatever those 6 DVDs were, she paid an additional $5.04. So 6 DVDs, well, we have 6 and we have DVDs, so let's just use D to stand for DVD. And we put a 6 in front of it. So that's 6 DVDs plus the tax, $5.04, equals $85.74. So now we need to solve it. So what do? Well, we start by subtracting. So we have 0 there. So that is now 6D plus 0 equals, subtract $5.04. So that's going to equal $80.70. So now we have 6D equals $80.70. Divide by 6, cancels those out, divide by 6, and D equals, again, get out our calculators, but it's, oops, I didn't write very well. It is 13.45. So that means our answer is each DVD costs $13.45. All right, that's it for this lesson. Hope that made sense. You have your assignment in ALEKS, and have a great day.